Okay, here we go. I should just stay here. I'll tell you what, I'll go ahead and put this on just in case. Okay, this section, a little bit more involved. I'm not quite sure how much time you've spent on this in the past, and if I can't remember. Seems like I've taught this to one of the classes here, but honestly, I forget. Rational functions. Okay, I'll get this so we can actually see it. I'll zoom out a little bit. Did you guys see the Northern Lights at all last night? They were really pretty cool. My wife's really into that stuff, so she's like, "Hey, let's go on out. Let's check it out." So we hopped in the car and drove around our grove so we could see to the north, and it was pretty cool. It's amazing how much it changed and how much it streaked, and it was pretty slick. Okay. Rational functions and their graphs. It might be locked.
From the county that 18th Road, the road that goes from Highway 32 to the school, is going to be closed Thursday and Friday. So tomorrow and Friday, 18th Road from the highway coming in is going to be closed, but you can go down into town and then back up to school. So you can go down 32, you just can't turn at 18th Road. So please make plans accordingly. Please don't try to use that road. They won't let you go that way, and it will hinder and congest traffic there. So thank you.
Okay. One thing I was really happy they did about yesterday, I don't know if you guys had to leave on 18th Road, is they had a very short section they were working on, so then the pilot car didn't take very long, and you didn't get backups. On the highway, they sure had a long section that the backups were kind of crazy. Okay. So rational functions and their graphs. So I'm just going to give you a quick example and get some feedback from you guys on what you remember. So if I had something like this, f of x is equal to 1 over x plus 2 and x minus 3. Okay. What this would look like, and depending upon your feedback, is how much I need to go into depth, and I will. And I'm not going to explain any of this right now. Ah, dang it, I put that in the wrong spot. Okay, and it's actually going to look like this. Does this look familiar at all? Okay. Okay. So I guess with hearing that it looks a little bit familiar, is that from pre-calculus or Algebra 2? Pre-calculus. Algebra 2 students, have you seen this before? Okay. Mixed responses. Okay. The big thing I want you to understand is why graphs do this. Okay? So one thing I want to start off with is just a very, very, very basic understanding of what's happening here. Okay? So let's start off with this. First of all, let's get some terminology down. These two right here, let's use colors. Those are called vertical asymptotes. Vertical asymptotes. Okay? Lines, or the graph never crosses a vertical asymptote. You don't cross vertical asymptotes. That's just all there is to it. No, 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 no. Okay? And there's a reason why, but we'll talk about that a little bit later. Let's go to a different color. This right here is a horizontal asymptote. Okay. Okay. Horizontal asymptotes, sometimes a graph will cross a horizontal asymptote, but it'll do so like in the middle. So you might have a situation where it does like this, and maybe sometimes your graph might, go up and cross it and then get closer to it. But usually with the horizontal asymptote, what we're considering is the very outsides. Okay? So a vertical asymptote, well, first of all, an asymptote in general is an imaginary line. It's not part of our graph. It's just an imaginary line that helps shape the graph that the graph at some point in time gets closer and closer and closer and closer to. Okay? Like if you look at this, it gets closer and closer and closer and closer to that vertical asymptote. Same thing here. If we're doing horizontal asymptote, if you keep going to the right, it gets closer and closer and closer. So asymptotes help shape our graphs. There's no doubt about it. Okay? So, let me explain why they blow up like they do. Let's say if I said y equals 5 over x, and I was just going to graph something like that. Graphing on any graph at all, you can always graph something by just looking at what you can plug in and what you get as results. Okay? So I'm just going to make a table of values. What the heck? X, Y. If I put in 1, what's Y? 5. So I have this point, 1, 5. 1, 2, 3, 4, 5. Okay? 2, 5 halves. 2, and it gets right there. Okay? 3, 5 thirds. Okay, that's kind of getting a little bit boring. So let's jump all the way out to 10. I get 1 half. So way out here, it's down to 1 half. So it looks like what's happening here is it's getting closer and closer and closer to that right there. So just by plugging in some values, you can see that it's got a horizontal asymptote. We are not going to graph these by just plugging in a bunch of values. Okay? Let's plug in some more points. What if I plug in 0?
Not possible.
Oh, I can plug in 0.
No solution.
Yeah, and you're right. Not possible, no solution, can't calculate it, can't divide by 0, whatever. So there is no points there at all that we can plot. So whenever you get a divided by 0, that is when we have a vertical asymptote. Thank you. Okay? So that's when we get a vertical asymptote. It's whenever we get 0 on the bottom. Okay? Okay. Where are you going? Bain?
Yeah.
Okay. Let me do this real quick. I got it. Thank you.
Mr. Extra,
Yeah.
the pre-calc kid said that you can make them memorize the unit circle or something like that.
Yeah.
This is the math.
Well, they don't know how to do it yet.
Really?
So, well, they don't know how I'm going to do it yet. They know how to do it.
Well, we had to memorize it, and then we got to use what we memorized on the test. Like, we fixed it after the test, and then we had to use it on the rest of the test.
Okay. So, and it's just a different way to approach things. It's, and I don't think there's any right or wrong answer. It's just, once I instruct, they'll go, oh, this is why, and then it'll be fine. But yeah, right now they're not happy, or at least they've expressed they're not happy. But I don't plot my educational course on what makes students happy. But I totally get where they're coming from. So anyway, so since I get 0 on the bottom, that's going to lead to a vertical asymptote. Okay? And so with that in mind, if we go back up to this previous one, you can see why we had vertical asymptotes where we did. Because if I plug in 3, that makes this part 0, so then it makes the whole bottom 0, and then we have a vertical asymptote. Okay? If I plug in -2, that makes this part 0, so then it makes the whole bottom 0, and we have a vertical asymptote. Okay? So vertical asymptotes happen when the bottom is 0. But I want to talk about really why more than anything. I'm just going to plug in some more points. And so if I go -1, it's -5. If I plug in -2, it's -5/2. So we're going to get the same points over here, but it's going to be negative. But let's go back to the original. If I go back and I plug in a number, 1/2. 5 divided by 1/2. What is 5 divided by 1/2? 10. Okay. What if I plug in 1/4? I get 5 divided by 1/4, which is 20. So as I plug in numbers that get closer and closer and closer to the bottom being 0, my answer blows up. And the reason why is because 5 divided by a number smaller than 1 is bigger than 5. When this gets closer to 0, this whole thing starts to blow up. For example, if I plug in 0.001, 5 divided by 0.001, 1, 2, 3, that's 5,000. So the closer I get to that asymptote, the lower my bottom number is, 0.001. 5 divided by a really small number is a really huge number. So that's why this blew up here, because the bottom was very small. That's why this blew up even negative, because the bottom was very, very, very small. Okay? So on a fraction, how do you make a number huge? Make the bottom small. So that's why it's going like that. Okay? So it's going to look like this. Okay. So let's make some rules. So if we have some rational function, I want to use the same variable they're using for this. F of x, they're just using a big old F. F of x. And I'm going to do a couple different things. Let's say I've got n of x over d of x. Any idea why I picked n and d? Yeah, numerator and denominator. Okay? Okay. So let's make a couple rules. Vertical asymptotes. Occur when d of x is equal to 0. So when the bottom is equal to 0. Okay? Trying to mix up the questioning here a little bit to higher and lower questions. What happens when the top is 0? Nope. I appreciate your response, but nope. Let's think about this. We decided vertical asymptotes happen with the bottom 0 because 5 divided by 0 we can't do. Okay? 10 divided by 0 we can't do. So that's from a divided by 0 issue. What if I have 0 on the top? 0. If I have 0 on the top in a different situation, it's 0. So what does that mean in this situation? Our height is 0. On a graph, when my height is 0, it lies like right here. So what's this point, that kind of point called? Intercept. It's an x-intercept. It's an x-intercept. Okay. So now, I'm going to introduce you to kind of my theory on the horizontal asymptotes. This is a confusing deal, but I want you to understand a little bit as to why. Let's just going to do some examples. Y equals 5x plus 1 over 10x squared plus 6x plus 7. I don't care. Okay? Okay. Horizontal asymptotes. A note about that. That's when x is getting really huge or when x is getting negative and huge. So the only thing I'm considering about horizontal asymptotes is huge numbers. Okay? Okay. So here's the deal. I kind of look at this as a tug of war or a battle between the top and the bottom. Let's plug in a number real quick. I'm going to just go ahead and if I plug in, you don't have to do this. I'm just trying to make a point. If I plug in 100, I get 501 on the top, so x equals 100. I'm just going to make a note. I get 501 on the top, 10x squared plus 6x plus 7. I get 100,607 on the bottom. Why is the bottom so much bigger? Because what? It's more variables and this squared more than anything. Okay? Because when I take 100 and square it, I'm ended up with 10,000. So this right here, this has a lot of power. And if we're looking at, like, say, if you're looking at offensive line or defensive line, if you've got one line that has more power, they're going to win all the time. Who's winning on this one, the top or the bottom? The bottom's winning because they've got more power. Okay? So if I start plugging in bigger and bigger and bigger numbers, what's it getting closer to? When the top gets somewhat big, but the bottom gets huge. It's getting close to 0. So, a note, when the bottom has a higher power, it will go degree. My horizontal asymptote is y equals 0. Why? Because it's getting bigger faster. It's winning that battle. Okay? Here's what I always think, and there's ways to prove this and stuff, but I'm just trying to kind of get it through conceptually. This thing is so powerful, this 6x doesn't matter, that 7 doesn't matter, this 1 doesn't matter, and even the 5x doesn't matter. We're going to get some number on the top, but we're going to get a huge number on the bottom. Okay? So that is when we have a horizontal asymptote at 0. Okay? And I'm going to summarize this with a table here real quick. Let's take a look at a different example. Y equals 6x squared plus 3x plus 5 over 3x squared plus 7x minus 100. Okay? Who's going to win this battle, the top or the bottom? They both have the same degree, have the same power. So it's going to be a pretty tight race. Okay? For example, let's go again. If I plug in 100, okay, 100, so I just got to type in 6x squared plus 3x plus 5. The top is 60,305. This is not how I would recommend you do this unless you are really stuck. Okay? 3x squared plus 7x minus 100. 30,600. Okay? So this right here, is this getting crazy huge? Or what's it about equal to? It's about equal to 2, right? Well, why is that? And why is it not exactly 2? It's equal to 2 because of this right here. We'll do a little leading coefficient analysis. Since my powers are the same, my horizontal asymptote is equal to y equals 6 over 3, which is y equals 2. Okay? Since they have the same degree. If they have the same degree, you're just going to take a look at your leading coefficients. If this bottom was 6, my horizontal asymptote would be 1. If there was no number here, what would my horizontal asymptote be? 6. If this was a 12, what would my horizontal asymptote be? 1/2. Okay? But you got to understand the power's the same. It's just the leading coefficients are what's going to make it different. What I find interesting is look at how close these things are to the top being double the bottom. That 3x, that doesn't make any difference. That 5 doesn't make any difference when I'm plugging in huge numbers like 100. That 7x doesn't make any difference. Even that minus 100, who cares? We're looking at when we plug in huge numbers. Okay? Okay. Let's do one more, and then we're going to go back and summarize this. What if I have y equals 4x squared plus 2x plus 6 over 2x plus 1. Now, after you've seen some experience with it, do you have any guesses as to what's going to happen when I plug in larger and larger and larger numbers? Top's going to what? Top's going to beat the crap out of the bottom. Top's going to get huge, and the bottom's not going to get as big as fast. So, is there anything keeping this just from getting bigger and bigger and bigger and bigger? No. So something like this has no horizontal asymptote. It might have a slant asymptote or a curved asymptote or something like that, but this one doesn't have a horizontal asymptote. Why? Because if I do the same thing, and if I plug in 100, I'll do the bottom here real quick. I'll try not to be too impressed. It's 201. Okay. 4x squared, hold the applause, plus 2x plus 6. I get 40,206. That's a big number. Divided by 201, yeah, we're up to over 200. So the graph would just keep going up and up and up and up and up. So there's no horizontal asymptote. Nothing stopping it from getting bigger. Okay? This is like a tug of war between the high school football team and the kindergartners. Oh, now. We all know there's a genetic difference between the two. It'd be interesting to play a game of volleyball, though.
Still boys. I think the boys are still.
Okay. Well, that's a whole debate for another time, which is probably not what we need to be discussing here in math class. Okay? Volleyball, I'll tell you what, I've coached volleyball for a little bit, it is a much more complicated sport than you ever would realize. It really is. It really is. I didn't have disrespect for it before I coached, but afterwards I was like, whoa, this is a lot harder than most people think. It really is. It really is. So, okay. So let's make some rules. I thought I would approach it that way before just giving you a rule. So here we go. F of x equals a ax to the n, and that's just going to boil down all the way down to nothing. And this is bx to the m. Okay? We're going to summarize what we just did. Okay? On this first one, this very first one, the denominator was bigger on the bottom. What did that get closer to? Do you remember? 0. So when m is greater than n, so when the bottom wins the battle, then I have a horizontal asymptote of y equals 0. Okay? And again, I didn't want to just give this to you and just have you memorize it. I want you to understand why it's happening. When m and n are the same, like we did on the second one, in terms of m and n here, what would we say? Well, first of all, does it have a horizontal asymptote? When the powers are the same? Yeah, it did. My horizontal asymptote is what in terms of m and n? Or in terms of these variables here, sorry. A over b. It's the leading coefficients that guide it. Since the powers are the same, my y, or my horizontal asymptote is a over b. It's a ratio of the leading coefficients. When n is bigger, when the top, there's no horizontal asymptote. Because it just gets huge. It just gets huge. Okay? Okay. So I'm going to let you chew that up and digest it for today before we do anything else. So here's what we're going to do. We're going to do page 291. We're going to do 1 through 3, okay? And you're going to have to factor the bottoms, okay? The bottoms, I just realized, are not factored, so you're going to have to factor it to find out where your asymptotes are, okay? So on this one, I want you to do 2 things. I want you to find your vertical asymptotes and your horizontal asymptotes. I want you to do 1 through 3 all. I want you to find your horizontal asymptotes and your verticals. Okay? And I want to do 9 through 15 odd. Now, it says to sketch the whole thing. I just want a sketch with the vertical asymptotes as dotted lines and the horizontal asymptotes as dotted lines. You won't have any other points on it than that. Okay? So what I'm looking for on that is maybe something at -2, maybe something at 3, and then if my horizontal asymptote is 2, then I'm just looking for something like that. Okay? Trying to hide your yawns. Okay. So that's what I want today. 1 through 3 all. Yeah, you'll have to factor it. That'll be good practice for factoring. Just be thankful I didn't do number 4. Okay? But, like I said, we're going to spend a couple days on this, and we're going to move on. Because I am really eager to get to something that is more useful in our lives, and that is the next chapter. The next chapter is really good. Really good. Go for it. Oops. Well. I suppose I should stop this recording.